Hi, and welcome to Meetings in Math. You are here for section 8.2, Perimeters of Composite Shapes. Our essential question for today is, how can you find the perimeter of a composite shape? Today you will need your Jaguar dots, starting on section 8.2, a pen or pencil, a highlighter might be useful. You may find a calculator helpful. Always bring your problem-solving skills, your determination, and your bright ideas. To begin, let's talk about what a composite shape is. A composite shape is a figure made of two-dimensional figures or shapes, such as triangles, squares, circles, rectangles, or semicircles. The perimeter is a distance around a figure. It's what outlines a figure from where you begin back to where you begin. So if you walked around a figure, or if you think about when you play your video games and you're checking the perimeter, that's what a perimeter is, checking that outside area. So let's begin by finding the perimeter of these composite shapes. To find the perimeter of a composite shape, first find any of the missing side lengths, then add all the lengths. Note, our images are not going to be to scale, so you can't use a ruler to find them. You have to use your math. And we're not going to use any estimation. So right off, you can see that we don't have a value for this side right here or this side right here. So we're going to use some math to find that. So the very first thing that we want to do is we want to take our 6 line right there. And what we're going to do is we're just going to drag it down. So we know that that's 6. And then we look for that parallel side, which we see right there is 3. And we'll drag that up. And we know that that's 3. So off of this line of 6 right here, we know 3 of it already. And so if we take 6 minus 3, we can find this remaining portion right here, which would then be 3. So we know that the length of this line is 3. And now we can use that same idea to find this one right here. We can take this length right here of 5, right here. And we know that this length right here, because it's parallel, is 2. So we know that this is 5. We know that we've used up 2 of it when we were coming down this way to find how much is left right here. So 5 minus 2 is 3. And now we have all of our missing pieces. And so if I was to start up here in the corner and go around like this, I can now find my perimeter. So starting right here, I'm going to add 6 and 2, and then 3 and 3 and 3 and 5. So let's write that all down as an equation. The perimeter P is equal to 6 plus 2 plus 3 plus 3 plus 3 plus 5. And when I add those all up, I get 22 centimeters. Don't forget your units and go ahead and continue to use that idea of an equation. So P equals 22 centimeters. So now let's look at one that's a little more complicated because it has slants in it. But we're going to use those same ideas that we used before to find the missing lengths. So we have a missing length right here, but we actually know quite a bit about it. We look for those parallel sides to help us out. So here we know the distance between this horizontal length and this horizontal length is 9. And so we can actually pull that over, that 9 over, and now we know from there to there is 9. Then we also know that from this horizontal length to this horizontal length is 8. So we can pull that over as well. And this time, instead of subtracting, we can add those together. And we know then from the top horizontal length to the bottom horizontal length is 17. And so then we go around. So I know this is 25. I know this is 17. This is 3. This is 8. This is 11. This diagonal is 10, this is 5, and I don't know this one. So this is that vertical length. But if I look back over, I know that same vertical length going from the top to the bottom. This one is the top to the bottom. So I can drag that one all the way over again, and I know it's also 17. So now I have all those sides again. I always happen to start in my upper left-hand corner, and I'm just consistent with that because if I'm consistent with that, then I know where I'm always going to start, and it just helps me make sure that I give all my sides. And then I always go around clockwise. So then my first one is 25, And then my next one is 17, that one I found. And notice, I'm not adding in the 9 because the 9 was inside. And then my next one is 3 plus 8 plus 11 plus 10 plus 5 plus 17. And I'm back to where I started. And so when I add all of those up, I get 96 centimeters. And again, I wrote out all of mine as one long equation so that the reader understands that the perimeter was the whole thing, and then my final answer. So we are writing equations to show the relationship between all of the numbers and then the final answer. So what about figures that include portions of circles? Well, the figures below are going to include parts of circles. To find the perimeter of the shape, we're going to use the circumference of the circle. Why the circumference? Because circumference is the fancy word that we use for perimeter of a circle. And then we can divide by 2 for a half, or we can divide by 4 for a quarter of a circle. I still use the fractions 1/2 and 1/4 just because I find that that's a much more clear picture of what's going on. But you can go ahead and use dividing by 2 and dividing by 4 in your own work. So let's look at these composite figures without straight lines. So if we look at this figure right here, it's made up of a rectangle and a semicircle. So the rectangle, you should be able to see right here, it's a 4 by 8. And then a semicircle is a half of a circle. And so you should see that half of a circle right here tagged onto it. So let's go through some of the different ways that we can find this. So part A, what would the circumference of the whole circle be? Well, in order to know the circumference of the whole circle, there's some things that we need to understand. One of the first things that you should always do is you should write down your formulas. Remember, you want to write down the formulas to free up your brain for the problem solving. So let's write down the formulas, and then let's also write down all of those different variables. You're not going to necessarily fill them all in right now, but at least you have a place to start. So now the next thing that I want to do is I want to figure out pi and diameter because we're looking for circumference. So the diameter means from edge to edge of that circle, which I'm looking at my circle and I don't see it. But I do have information. I have this 4 right here, which does help me out. So just like in the previous ones, if they are parallel, I can drag them up. So that can drag all the way up right here. And I know that that's the radius of 4. So if that is a radius of 4, then I know that I have a diameter of 8. Remember, 2r, 2 radius, equals 1 diameter. So I fill that in right here with my diameter of 8. I'm just keeping track of things as I find them. So I can put that in, that I have circumference equals 8 pi, and we write it 8 pi because that makes more sense. So let's go find the circumference of half the circle. How do we go do that? Well, we take half the circumference. So 1/2 of 8 pi. This is why I like keeping it as pi's, because I can do 1/2 of 8, and 1/2 of 8 is 4. Now that I have that half of the circumference is 4 pi, I'm going to go ahead and change that into the decimal now. So 4 times 3.14 is 12.56. This just made it easier to keep it and make that calculation at the very end. And so now I know that to go around that semicircle portion from edge to edge, so that means from this edge all the way around to this edge, is 12.56. So now we need to figure out the whole perimeter of the whole thing. So let's go do that. We know that this was 8 because it's parallel and it goes same edge to edge, so that's 8. Now I need to find this one, but we're really close to it. We know it's 4 because if the diameter is 8, right? We found that out over here. Then if this is 4, then this has to be 4 as well. So here's my guide to keep track of where I'm going. So I'm going to go starting right here, 8 plus 12.56 plus 4, that's this 4, not this one because that's inside, plus 8 plus 4, and then I'm back where I started. And so when I'm done, I get 36.56 meters. So we're going to get to the part in our math class where we do lots of little pieces, lots of little problems to make up our great big problem. So we want to keep track of things. We want to make little notes of what it is that we're doing so that we don't lose our work. Now let's try this one. Let's examine what it is that's happening with this figure. What I notice is that this is made of 4 semicircles that have the same diameter. And so when I put in my little guy, I notice some things right off the bat. When I start going around, I notice that he's never on any straight lines. As he goes around, he's always on some kind of a curve, which means this entire time that I'm going to be working, my plan is going to be working with circumference, which is pi times diameter. And again, I'm writing this down so that I can think about my problem solving and not my formulas. And so I just start working on that. So again, I need my pi and my diameter, and I'm lucky because my diameter is right here. It's 3 meters. And so I plug that in and I get to work right on that. So I do some substitution where d is equal to 3. And so I know that c is equal to 3 pi. So this is the circumference for the whole circle. And so now I need to figure out, well, what's going on here? So that's if I had the whole circle, but this isn't a whole circle. This is a half of a circle. So since these are only semicircles, I need to divide that in half. So half of the circumference is 1/2 3 pi. So I'm going to go ahead and make that 3/2 pi, which is a little bit ugly right now. And so let's go ahead and put it into some kind of a decimal. So we'll take the 3/2 and make it into 1.5 and our pi into 3.14. And so 4.71. So to go around one curve is going to be 4.71. That's just one curve, but there's 4 of those. So each one of those is 4.71. And then what do? Well, we just add those up to go around the whole figure. So I'm going to add those up and I get 18.84. So that's how we do that problem. But it's interesting, if we want to think about this, can you think of another way that we could have done this in less steps? And there's a really interesting way that, if you can think about it, to do this. So not every single time that you do this problem, do you always have to go 1/2 of that and then add them all together. You can use some logic to do less steps. For example, you know that that's a half of a circle. But what if I slid it down here? Suddenly I have a full circle. What if I took that half and I slid it over to there? Suddenly I have another full circle. So instead of doing each curve and adding it up like I did in the previous page, what if we really just took the 2 circles with the same diameter? So now instead of taking 1/2 and then adding it up 4 times, what if I took and said I just have 2 circles, and I went around this circle and I went around this circle and took my circumference and multiplied it by 2. So now it's 2 times 3 pi, which would be 6 pi. Multiply 6 times 3.14 to get to 18.84, which is the exact same number we had before. So there are going to be times that you might actually see a pattern where you could rearrange something in a way that you could actually save yourself a few steps. It doesn't mean that you always are going to find it, just sometimes you might be able to find it. Thank you so much for joining us today in the perimeters of composite shapes. This is a really fun time where we get to see some real life examples. I know we didn't get to them in our example today, but in class we'll get to see some. I want you guys to think about what we can do to find those missing sides of the composite shapes. And remember how we kind of remember the sliding side? That's going to be a big help. And how does it change when the side is curved? Because then we had to do something different. Thank you again so much for joining us. And remember, be kind to one another because we can all use some extra kindness in our lives. Bye for now.